Hey there everybody, I'm Antonio, and today we're going to learn about hard pressing our powder that we've made into a pellet. Now we have some pre-prepared YBCO here that, if you recall from our last videos, what we put together. But it is mixed with 5 grams of PEG 3350. 0.5, sorry. Which is, thank you, which is a binding agent that's going to help it, when it's a pellet, retain its shape and structure. And that, for those of you who are curious, is Miralax, a laxative that you can buy over the counter. So before we get into the actual measuring out of our powder, let's talk about how we're going to press it and what we're going to use to do that. And we'll do it with this die. This die has a collar, that's this center piece here, and this particular one is a 1/2 inch size for the pellets that we're going to make, and it has a bottom and it has a top plug, and you can clearly see which one goes into which. The top one is slightly smaller, the bottom one is slightly larger. But before we measure out our powder and put it into this die and into the collar, we don't know where this has been, so we're going to clean it. And the way we're going to clean it is by, if I can grab a Kimtech, put a little bit of ethanol onto a wipe, and we'll give it a good rub down. Make sure that there's no residue from anything left on there that someone else may have used before. No, I actually don't have a disposal.
So I'm going to go grab a waste disposal for you, just like any time before in any of the other parts. If you get YBCO on a chem wipe or a spatula, and that's anywhere, anything that has that YBCO or any of the precursor powders, we want to make sure it's disposed of properly. So I'm going to go grab that.
Exactly. So Nancy's made those waste disposals for us. All right. So see, even there, you see it looked clean, but as soon as I rubbed it with the wipe, a bunch of powder came off. So here's our disposal tub, just like that. And then while I'm doing this, I'm going to clean off this spatula that I'm going to use because, like the die, I don't know who's been using it, where it's been. So we're just going to give it a quick rub with ethanol. Okay.
So today we're just going to do the demo of dry pressing, and so the powder that Antonio showed you a second ago is from a previous semester, and then we've added an amount of the PEG 3350. So this is going to be comparable to one of our conditions that we will do later. So this is going to kind of serve as what the dry pressing process looks like. And then when we have your powders, which you've seen made in other videos and have pictures and so forth of, when we have that, you can kind of assume that that's the process that we'll go through, and we'll take lots of pictures along the way to show you the pressing forces, the masses, what the pellet actually looks like. So this is going to kind of serve as a general what we did, and then later on you're going to see a lot of data in the photos that allows you to look at what you have.
Yep. So here we have our plastic boats. I'm going to set it into the middle of our balance, close the door, and tear the mass of the boat.
Let's see if I can get that to you.
This actually did super quickly.
All right.
So you see there, it does say negative 0.0007, but that's okay. We can expect it to fluctuate. Now I'll open both glass doors. And I'm right-handed, so I'm going to use my right hand to hold the spatula, and with my left hand hold the vial with the powder. And today we're going to measure out 1.1 grams of this mixture of YBCO and the PEG binder.
So if you recall from the lab handout says 1 gram for these smaller 1/2 inch dies. we are using 1.1 because we've added binder, right? And so if you remember from the vial that Antonio showed you a minute ago, we had 5 grams of YBCO and 0.5 grams of the binder PEG 3350. And so if you do the math there, that's 10%. And so we are scaling up the amount we need to compensate for the addition of a binder. So also, you'll notice that Antonio is using that same technique of vial in one hand, the spatula in the other, on other opposite sides of the balance, just like we did in the batching video. This is to ensure that there's very minimal mess that happens when we do the weighing out of these chemicals.
And here I've gone just a little bit over 1.16. So I'm going to try and take a little bit out, and like we did in the last video, instead of putting it back into the container where the bulk powder was, I'm going to place it onto this wipe for disposal later. And I'm happier with that. I'll close the glass doors. There is our measurement of our mass.
All right. So when we show you your pellets as they're being made, we will take photos or videos of these masses as we go through the process. So we'll have a mass of the powder that we've used. You'll know what the condition is in terms of how much binder is being added and so forth. So we'll give you this mass. And also, as Antonio's going to go through, we'll also get a mass of the pellet after it's been made with this next step. So there's the possibility that we lose some mass as we go from here. So I'll let Antonio take back.
All right, great. So I'll start by putting the bottom of the die into it, and it'll click into place, fit nice and snug. Place it in, and then with the boat, you can easily pinch the plastic and fold it into this taco shape. And then you can help with the spatula and scoop as much of it as you can get into the center of the die. Tap it out. And there we go, that's pretty good. So you can see a little bit got onto the lip there, and a little bit is still stuck to the walls of the boat. We will, once we have the pellet, measure the mass again to see how much we have lost in that respect. Now, to put the top on, we won't press it too hard, we'll just place it in and twist it a little bit so that it gets nice and evenly pressed onto the top of the powder. Now if I grab the die by the collar and lift, the bottom is just going to fall out and all the powder that's inside will spill, make a big mess, and we don't want that. So it's very important anytime you lift this to grab it by the bottom piece, right, to make sure that it doesn't fall out.
One last thing, can you show the label there? So this is another way, it's a little hard to read on the screen, but you'll probably note, let's see if I can zoom in a little bit, the glare is kind of taking it. So that writing also tells you what direction you have. So you want to be able to read. It says 1/2 inch. If you can kind of, yep, that's perfect. And then below that it says 12T. So that's the maximum that this die can withstand. And so whenever we're doing our pressing on these machines, you want to make sure that we're not surpassing that 12 tons, or this die can malfunction, and that is not a great thing to have happen. So you want to be able to see this in terms of, so when we talk about top and bottom, you should be able to read the thing and be able to tell top or bottom in that case. So you can also see on the back side, there's the company logo for this as well.
Yep, and those are 180 degrees apart from each other, and that'll help us, and if we remember that in just a second, when we put it into the press.
So we're moving straight from the fume hood, so hopefully it isn't too long where you forgot where everything is, but I'll just kind of pan. So we're walking across, and half the class will have done this, but we want to make sure everybody is kind of familiar with where this is in the lab for future instances. So this is one of the presses, and let me come over and just kind of give you a tour of this. This is a Carver press. I think I can kind of zoom in here on the model number should be there. It's 3912. This is a hydraulic press from a company called Carver. So this is the one that we're going to use throughout the pressing. Some of the larger pellets, we might have to use a larger press, and if we do so, we will let you know, and we'll show you pictures of that or video of that machine. So I'll give it back to Antonio.
All right, so one of the things you may have noticed is that the base plate here has concentric circles. This can help you to place the die as centered as possible. Not all of the presses that we have in this lab have that, so that makes this particular one easy to use, and you can see this warning here that the loads must be fully centered, anything that you put in there. All right, so I'll close this little door and turn that to hold it in place. And if we look here on the bottom left, we have two different gauges. One of these gauges goes from 0 pounds to 5,000. That's the one on the left. The one on the right goes from 0 to 24,000. Now, depending on how high of a load we want to press on the sample that's in there, it will change which gauge that we're using. For this particular demonstration, we're going to apply a load of 1,400 pounds, which is well within the scale of the left gauge. So in order to activate the left gauge, this knob here, you can see on the camera, there we go, I twist it to the left and it'll stop. And that will tell me that this gauge is open and reading the force. If I were to apply a force that was above 5,000 though, I would want to twist this to the right until it stopped, and then only this gauge would be reading force. That protects this gauge.
Can you go back and just, so what was the maximum on this gauge on the right?
24,000. Okay. Did I say the wrong number?
No, I think it was for me. I forgot. So.
All right. So I have this twisted all the way to the left. I'll be reading from the left gauge at 1,400 pounds. And so remember, we are going to do this twice, rotating the sample 180 degrees in between each trial. So right now I have the label that says 1/2 inch facing out. And I'll start to apply the force by pumping this lever here. And at first, if you want to see on the gauge, or I can just tell you, nothing happens. It doesn't move. It's because it hasn't quite made contact yet. But once it does make contact and start to put force, the gauge finally starts to move. And this is something I didn't explain when I first started, but I will now. Well, thank you. Is that these red needles are adjustable. Let me adjust the red needle on the right one so you can see it. These red needles are adjustable, and they have a little stopper on the inside of them so that you know when you hit it, your target force, the force that you're trying to achieve. So I preset on the left one this at 1,400, and then I pump the lever until the black needle lined up with the red, until it touched the red one. And then it's at this point that I would ask if there were any pressing questions.
Ha 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 ha.
Right.
So we've also got a handy timer here, because again, like Antonio said, we're going to do 1 minute on each side.
Mm-hmm. All right, so there's my 1 minute. There's a second knob here at the bottom of the press that if I turn to the left, it'll release the force that's being applied and lower the stage.
So make it So here you can see that the dial went back to 0, meaning no force is on the die. Also, it might be a little hard to see there, but there's a little bit of gap in between. So we've lowered this bottom ram so that it's no longer in contact with the sample. I'm no longer applying force.
Yeah. And I'm going to turn it 180 degrees. So now the company logo of the die is facing directly out.
Again, you might not be able to see that super well because we are having some lighting issues. We are not professional video
cinematographers.
Yes, exactly. We are not winning an Oscar for this presentation.
Roger Deakins. All right. So we'll repeat exactly what we did. If you want to watch the black needle here. Very good. So I'll start. Yep. I'll start pumping, and you see, it needs to move, and it makes contact with the red needle that I preset. And we'll hold that for 1 minute.
Started the 1 minute timer. Switch positions. Sorry if you get dizzy because of that. And then wait a minute. Interesting time as we go along, and wait the minute. So when we do these pressings for you, these dry press to make these pellets, we are going to take pictures along the way because we don't want to have to do a video for every single pellet that we make, because you'll see as we go through how many there are. And so we're going to sort of use our camera and get pictures along the way of the force gauge. We'll get pictures of the masses. We will give you images of the pellets themselves with a ruler with the scale bar, and we'll show you how to do the analysis to get dimensions for that. And so we'll kind of give you all of those, and we'll try to have it nice and neat in the Google Share Drive so that you have that data and just kind of have to watch one of these videos to show you what's happening on those videos.
All right, so I turned this knob to lower the sample, and now I can reach in. And remember, we said whenever we move this, we always want to hold the bottom plug so that it doesn't fall out and everything spill. What I'm going to do here is turn this upside down, keeping my finger on the top plug, and now gently remove the bottom piece. I'll set it aside, and if you look inside the die now, you should see the pressed pellet.
So that black area that you see, so if it was not there, you would just see the top plunger piece. So that black piece, that's our sample that we've made.
Yep. And so we've developed a little technique to pop the pellet out without damaging it significantly. And we'll do that by placing this on this second press to the side here, or specimen mount press.
So same idea here. This one's just better suited to eject our sample. And so make sure the same thing like you do the other ones. The other ones has a centering indication. This one we have to more manually center it, but it moves a lot faster. And so we center it. You'll notice that when Antonio did center, if he was pressing, he was making sure his fingers were not going to be in between anything. So you won't always want to have those outside. The biggest issue with this press, as you might imagine, is pinching or any sort of way that you can get your hand or fingers or anything inside this press. So
great. And so here's the force gauge on this press, and we're actually not going to apply any force onto this, because if you come back up to the sample, all we're doing is pushing the top plunger all the way through.
And so as this happens, if it doesn't move, if it doesn't drop down, we will stop. We don't want to apply any force. So you'll notice here it's getting pretty close, and so we want to make sure that we stop before any force is applied, because we don't want to get that top piece stuck in this die. So that's kind of the main hazard here. So we're very cautious when we do this ejection. We can always apply force and ruin what we have.
And I feel a little bit of resistance in the lever, so I'm going to immediately stop and turn this knob to release
So same thing, that knob is releasing the hydraulics and lowering the container, the die.
Okay. And again, being careful to hold the top. And now, if you want to look down in there, you can see the pellet. So where am I?
So the focus isn't that great here, but again, the pellet's going to be in there, but now it's not stuck inside the die.
And then I'll show you how we very gently remove the pellet from the collar. We'll do that by just holding the bottom on the inside. Let me tilt this way so you can see. I'm just holding the bottom in there, not pressing it in at all, setting it on the table, and then rotating this to stand straight up so that when I lift the collar, voila, our pressed pellet has been made.
There.
All right. So now that we have our pressed pellet, there's a couple of things that we want to do. We want to take some measurements about the size, the dimensions, and we also want to measure the mass, record the mass.
So we've got a ruler here, which is a very nice ruler. So I'll do it for the video here, but we'll also have some stills, some photos that we'll upload to Google. But you can kind of imagine what we're doing here. So if we want to know the thickness of the pellet, we're going to have the ruler next to it. We're going to get a nice straight on view of the thickness of the pellet. And what we can do is, we will do this in a further video too, but we will take a picture with this scale bar. So we've got what length it is in this photo. And then we're going to use a program called ImageJ and apply that scale bar and then be able to interpolate what the thickness of our pellet is. So from the video it's not going to be that great, so don't worry about trying to get stills from here. We are going to get some photos of this, and then we will have those uploaded as well. Also, thickness. So if you want to get the thickness, obviously you're going to do it some version of this direction with the scale bar held there as well. Also, I'll just kind of hold this pretty close. Hopefully you can kind of, as it's focused, you can kind of see some of the physical properties of the pellet. So this was pressed at, if you remember from the force, 1,400 pounds. That number should sound familiar. That is very close to the measurement that you had for 50 megapascals when applied to a half-inch pellet, right? So that's what we're shooting for here, is 50 megapascals of pressure, and that's how much force we have to apply for that cross-sectional diameter. And so the next thing that we are going to do now is we have to take the mass of this pellet. So we've got it resting on what was the bottom punch, and so we want to basically record the mass, because we may have lost mass as we've gone along. So we want this to be our mass of the pellet plus binder before we put it in the furnace for sintering. So we have an initial mass. We can calculate the density at this state, what we have, by the dimensions and the mass, and we can see what happens during the sintering process. So to get the mass, Antonio is going to take these weigh papers. So we have made them smaller. You can also use smaller weigh papers. So this is just enough to fit on the balance that we've been using. So what he's going to do is we're going to take a piece of this weigh paper, and we're going to tear the balance with this torn piece of paper. That is Antonio's pun, second pun of the day. He's workshopping these in the previous group. So the idea here is that we're going to tear this weigh paper, and this is going to be what we set the pellet on. So we teared, whatever you want to say, this weigh paper. So now he's going to take it back out, and we're going to come back to where that pellet is. The doors on the balance are a little tricky. If you were here, you could see that too. So bringing the spatula along. So the idea is, and I'll let him concentrate on the actual pellet here, but we're going to try to transfer it onto this way paper so that we can get an accurate measurement of the pellet. So he's using the spatula to push it off onto the way paper, and he's also made almost folded it a little bit, almost like a taco, so that when the weight of the pellet hits the way paper, it doesn't cause it to fold over. And so now he's going to carefully, and I'm going to get out of his way, take that way paper that's been previously tore twice, and he's going to put it back on the balance. So now the added weight is going to be from the pellet, and so we'll know what the mass of this pellet is going to be as we go along. All right, it's stable there. So we've got the mass. We will take, you will have measurements of the thickness and diameter. From those, you'll be able to get volume and density, and that will help us to determine the density of this, what we call green state. And so I'll be explaining this a little bit more in the upcoming lecture, but the green state is basically before we center this pellet. So we've got the masses there on the whiteboard. So you can see that we did lose some mass between the initial mass of the powder and then how much is left over after this pressing. All right, so what we're going to do now is Antonio is going to bring that back over to this sort of empty space that we have, this open space on the counter, and we're going to set this one aside. We'll have photos of it for you, and then Antonio and I are going to press one more using the same procedure, and I'll keep the video on, but he's going to do another one, and the main modification is going to be, in this one, we used a force of 1,400 pounds, which again, if you did your calculations with us, that should be 50 megapascals, and he's actually going to write that down so that we know which one is which. And then this next one, we are going to apply a force of quadruple that number, so approximately 5,600 pounds, and we're going to apply that, and so that should give us, if we're sort of following along, close to 200 megapascals. And so we are going to press those, so you kind of, again, see the whole process. And then what we're going to do is we're going to actually take our spatulas to these pellets, and we're going to give you a sense of how strong they are under these two conditions, because this is going to be part of what this experiment is about, is what does the binder do and what do these forces do for you. Sorry about that. I received a phone call on my computer. Technology. So we'll sort of, I'll probably narrate less as we go along with this one, but I'll follow Antonio along as he makes this next pellet.
Step one, clean.
So even if you're the one that used it before, even if it's the same exact powder, it's good to get any residual powder off of that. If it gets stuck, then that's obviously a bad thing. Anything that gets stuck on the die is not in your pellet, and so we want to try to minimize all of that to happen. So we're going to clean it each time, again using ethanol, something that dries very quickly, so we don't have to wait for it to dry. And so we're going to clean those.
And the boat that we used from last time also is going to go into our disposal bucket. Let's see. One more thing, spatula. And then recall that when we were measuring it out, we measured out a little bit too much. So we took some out, and instead of putting the excess back into the container, we put it on this wipe. We're just going to pinch that and put it into the disposal.
So in general, when you're in the lab, so this will carry over for other labs that you're going to be in with us, and also in senior design. Obviously, we know what we're doing. We know that that's YBCO. The next person that comes in doesn't know that that's YBCO. Same thing for beakers of random clear liquids. That's the big one. Is it water? Is it hydrochloric acid? We don't know. So make sure you're always very considerate of that. It's, anybody that's doing the experiment, it's their job to make sure that that's clean. It's not somebody else's, so make sure you take care of your own stuff. So we're going to try to stress that. Nancy does not like it, nor does anybody else like it when they come in here and sees some random powder. So you want to make sure that you clean that up.
Especially if it's toxic.
Especially if it's toxic. So that's one thing, again, that you should be looking at. You're not doing this in person, right? So there's no hazard to you. Congrats. But it is a good practice, like we've done with the job safety analysis. And will probably be a part of this exercise as well, is to look up the MSDSs for these materials that we're dealing with. So we have the barium carbonate, we have the yttrium oxide, copper oxide, and then after we've synthesized, we will also have YBCO, which can have its own hazards and has an MSDS of its own. So again, it's very common to spill these things. As you can see, me and Antonio have been keeping hydrated with our coffee, and so that can give you a little case of the shaky fingers. And so the good thing that we have, Nancy has set up for us previously, is this paper that you'll notice all throughout. So if this gets spills on it, what we're going to do is we're just going to take the whole thing, put it in the waste container that we've seen before, right down there. So when we're done, if we have excess powder on any surface, we'll do that. Same thing for the previous videos. You probably saw us wear those disposable lab coats. They were very fashionable. If those end up getting powder on them or any sort of chemical, we can also put that in the same waste container as before. All right, so Antonio wrote down his second mass here. I don't know if I got a very good look at the camera, so you'll have to trust me on that one.
Yeah, trust me. All right, so the bottom piece. The taco.
You'll also notice that me and Antonio have referenced tacos multiple times. We are here at 11:30 in the morning doing this lab. So just as you remember from doing these labs, towards the end of the session, tend to get a little hungry.
Top piece. Fit in nicely. We hold from the bottom. Okay. Twist. Open. So see, we need to lower it some more.
Didn't quite fit. So again, we can twist the knob here to lower it, and then you can see now it fits.
And we'll start with the logo facing out.
See if I can get that. I cannot. It is the logo of the company.
And now this time, we said we were going to
5,600.
5,600.
And so if you remember the limits of the scales, the left one only goes up to 5,000. And so we cannot use that scale. These gauges have maximums. If we go past that, we tend to break them. And so we have closed off the valve by turning it all the way to the right. So that means that no pressure will get to the left gauge, and that will protect that left gauge. And so we now only have access to this one, which has a max of 2,400, and we are going up to approximately 5,600.
Which we set with the red needle.
So the red needle is just the indicator of I want to go to this, right? So we're setting this ourselves. The black is telling us the actual pressure. So we're trying to match those two when we do it. And so when we pump, we are applying pressure. The initial pumps move the ram up and causes the ram to move inside the die. And so it'll compact the powder. Initially, you probably won't see force, but then as we compact everything, you'll start to have more and more of a force. We set the 1 minute timer. Antonio matched that, so we're pretty close to 5,600. From this gauge, you'll probably be able to tell that there is going to be some level of air. So if you calculated 5628, right, you're probably not going to get that precision on this instrument. And so we're going to wait the 1 minute.
Guess you could say we're hard pressed for entertainment. Trying.
We will probably, we're not guaranteeing it, but we'll probably get better at puns as we go along. So, release the pressure by turning it to the left, the valve. That lowers the ram, and then we can rotate the die 180 degrees so we see the other logo. And I won't even show you this time because it's not showing up very well on this camera. Close back up the safety shield. If anything bad were to happen, this shield is there. Again, we are paying attention to make sure that we are not exceeding the maximums of this die. All right. And again, if we want to sort of go back here and look at the red dial here, the red dial tells it to us in metric tons. So you'll notice that the maximum there is 11, right? So the maximum ton capacity of this die is 12. So as long as we don't exceed 24,000, then we will be okay, right? So we're well under that for this die. But it's always a good practice if you do any sort of dry pressing on your own. Always check the die and see what the capacity is. As we go throughout, we'll show you the other dies that are used, and we'll take some pictures of the outside so you can see the similar restrictions. The bigger the die, the more pressure it can take, and so as we show you the bigger ones, you'll notice that those can withstand a lot more pressure, but it's always unsafe to use things outside their required amounts.
That's good advice.
All right, so we're getting the die out, holding the bottom as always. Flip it over, take out what is now the top, which is the bottom piece. Again, sorry,
Yep.
We're both trying to correct.
Yeah.
All right, we're going to eject. So push the plunger through using the other press here and try to remove the pellet from inside of the die, and then we'll do the flipping technique. So Antonio is actually the one that kind of developed that flipping technique that we'll see again. It works really well. One of the things that we want to do is we want to avoid any sort of damage to the pellet, and so that's a way that we can ensure that it doesn't fall too much. All right, so this should be good. All right, that's enough.
Yep.
And then so instead of having that pellet drop out of this die, that's how we've sort of developed this technique. All right, so it should be out. You might see some sort of flakes that come off. That is okay.
All right, and then remember we'll place the bottom inside, not push it, just place it in, so that as we flip this over, and then lift the collar, the pellet, is saved.
So you might have seen a little bit of the powder come out. That is okay. Sometimes the edges can chip and so forth. That is possible. Again, for scale here, if you want to see this, we'll also take some some images of this, and then also the top. With this video, it might be hard to tell the differences. After we take the mass here in a second, we can put them side by side to see if you can see any differences in the two pellets. So same process. Antonio is going to take that piece of whey paper, tear it, and then bring it over and transfer it onto the whey paper, get the mass, and then we will sort of look at what the differences of these two materials. So we've got it teared.
This is not the same spatula, but we'll forgive it.
So we're using here a different piece of the spatula, the backside. As long as we can scoot it, we're trying to minimize the damage that we do to it. Again, you might see some little pieces come off. That is okay. We will account for those. And so that's always going to be a source of error in dry pressing. If pieces come off, if you are assuming it's one shape and there's little chips that come off, right, that is all of our sources of error in this experiment. So we've got our masses here on the whiteboard again. So pre and post pressing, how much powder, and then again you see that we did lose some. It's not a whole lot, right? But it's important to kind of keep track of what the mass is and so forth.
Okay.
All right.
And this one was at, what did we say, 56?
Yep, 5,600 pounds. And we're doing pounds here because these presses that we have predominantly do that in English units, and so we just want to get the best reading we can. All right, so here I'm going to try to get as good image as possible here. So these are our two pellets. Again, we'll take some images when we stop this video. So actually, we are going to, I'm going to go ahead and stop this video, and then we will start back up with a short video, or maybe attach it here we're going to basically try to break these and see what the properties look like, but we're also going to take some photos of the samples along the way.
All right, welcome back. Now we've taken some photos of the dimensions of our two pressed pellets, one at 1,400 pounds and the one pressed at 5,600 pounds. And we're going to do a little informal experiment today, a little test to see how easily we can break each one of them, how fragile they are, how much they'll chip, and any other observations that we might find. So let's start with the 1,400. Start by tapping it some. You can see that quite a bit's flaking off there. Oh, there we go. I chucked off some major bits. It was pretty. Oh, there.
Otherwise,
two big chunks.
Generally, you can kind of, if you just break it in one, it will kind of chunk into pretty large pieces. But any sort of pressure tends to basically break it back down into a pellet. And so, and that's something we're obviously looking at with this experiment is what role did the binder have? So we didn't give you a control here of what this looks like with just the YBCO. We will see this as we do the experiment. This was just a kind of demo, but we will have a control of what YBCO by itself, how that behaves, and we'll be able to sort of compare that. So this was the 1,400 pounds or 50 megapascals for this amount. And so now we'll sort of shift gears and look at now quadrupling the force and the pressure. And so what happens in this case?
Oh, man.
So you can hear it, hopefully, that he's applying quite a bit of force repetitively. You can see some stuff chipping off, but overall, this thing is together. So finally able to kind of wiggle. Oh, there it goes.
Very good.
So again, some observations. We are not measuring force, but it seems like it took a lot more force and repetitive pounding to kind of get this into multiple pieces, but still into these really big chunks, right? So what that means for us, and what we'll sort of be doing this with this experiment, is we've added this binder because dry pressing can be difficult. If you press these powders together, if there's nothing else there, the only thing holding this together is these very weak sort of van der Waals forces between these powder particles, right? So what we've done is we've added something like PEG 3350 as what we call a binder, right? So you can kind of see the effect of added pressure on this binder and YBCO system, right? So in our experiment, we are going to be looking at different amounts of binder and see what role that plays, right? So we want to see what that does. If you'll recall in the last lecture we had, I kind of went through what the kind of binder does, right? It kind of deforms around these powder particles and holds everything together while it doesn't have this strength. So in this green state, we've given it what we call green strength, right? So we can more easily handle it. So on a commercial scale, you can imagine we needed to have some strength for this process, right? And so here, what we're kind of looking at is what role the pressure has on the binder, but we'll also look at the opposite there. We'll look at if we have one pressure and we adjust the amount of binder, what role that has. And so that's what our experiment is going to be, that we'll be doing for you, but that you'll be following along with us. So, again, observations here, should be making this in your lab notebook as you go along. These are just kind of 2 demo pieces. We'll also have data as we go along for your specific powders as we make materials from those with the added binder. So you'll be seeing a lot more of this. This was just a demo to show you the different strengths here and the dry pressing process as it goes along. So we'll end it there and see you next time.